All right, this video is for those of you that have struggled to be able to find the molar mass when given a formula. So the objective of this video is to help you be able to determine the molar mass of a substance when given the chemical formula and a periodic table. So just so you know what success looks like, hey, if I do this, then I know I'm actually doing what I'm supposed to. You would be given a question just like this. What is the molar mass of CO2? Then you would use your periodic table to figure out that it is 44 grams per mole. So let's just go ahead and jump into that. I'll go to the next slide. So the first thing you need to know is how to use your periodic tables. So there's the one on the wall. There's this one here. This is the one that's printed for you. The mass of an atom that you'll need to be able to figure out, or compound when we add all the masses, we look at the larger of the two numbers in the box on the periodic table. So for beryllium, just plain Be, it would be 9 because that's the larger number. If we're talking about boron, it'd be 11 because that's the larger number. Zinc, it'd be 65 because that's the bigger number. All right, hydrogen, it's a 1. Now they're the same number, so whatever, neither one's larger, but they're the same, so it doesn't matter. So anytime we use the periodic table to find the mass, it's always the bigger of the two values. The smaller one is the atomic number, but mass is what we're definitely more worried about. So make sure you use the bigger number as we go along here. Okay, so let's just hop in. And these things right here, these are just snippets from the periodic table I took just to save us some time from having to flip back. So I just took a little section here and here so we'd have the two element masses we need. So it says find the molar mass of C6H6. All right, if there are subscripts, which this one has, we have to account for all of the parts here. So this C6H6, it consists of 6 carbon atoms, and it consists of 6 hydrogen atoms. Now I'm going to put a plus sign in between these two. So what we need to do is first determine how many of each type of atom there is. Then we multiply that number by what the mass of the substance is. So carbon, I look over here, I find the bigger number. The mass for carbon is 12. But since there's 6 of them, I need to multiply 6 times 12. Then I'm going to add 6 more parts, and the mass of hydrogen is just 1. So I'm just going to put times 1 right here. So 6 times 12 is 72, plus 6 times 1 is 6. So we get 78 grams for every 1 mole. Now this is the unit. It's grams per 1 mole. I'll often just connect the G and the line. Okay, so just quickly one more time. Determine the number of atoms there are for each one, and then multiply it by its mass, that is the bigger number, and do that for each type of atom and add them all up. Okay, so we have this one here. This one is slightly different because it has parentheses and a number on the outside. So when we have a 2 on the outside, it means I have 2 of everything on the inside. If I were to draw this compound out, it would be Mg and then an N and 3 O's on both sides of it. All right, you can see that in the formula. I have Mg stuck to 2 things, and the 2 things are the N with 3 O's. So if you count all this up, you'll notice that we have, I'm going to put it right here, 1 Mg. I have 2 N's. I just distribute that. I don't know. I didn't put that in parentheses. I don't have to, but whatever. Plus this time 2 times 3 makes 6 oxygens. You can see it. 1 Mg, 2 N's, and 6 oxygens. Okay, now I would use the periodic table to find their masses. So I come down here, Mg is a 24. So you wouldn't have to write this out, but I have 1 times 24 plus, I'm going to say 2, and then N, I find its mass right here is 14. Plus 6, there's 6 oxygens, and its mass is 16. All right, I better pause this because I don't know that answer in my head. All right, when I did that in my calculator, I got 148 grams per 1 mole. You can check me on that. If my math is wrong, I apologize. All right, so hopefully that went okay. Let's try this one. Whoops. I thought I had one more. I don't. All right, I have this one. I wanted to do a little easier one before this, but that's okay. So if you would pause the video and try this on your very own, just real quick before you do that, this is chlorine right here. This is chlorine, not a C and an L. That's what this is saying. The letter after C is a lowercase l, so it's talking about chlorine. Pause it and give this a shot. We'll walk through it together after. Okay, so I'm going to bring it down here and over. So I have 1 calcium, plus I have 2 chlorines. That's because there's 2 of these. All right, and then 2 times 4 means there's 8 oxygens, and each oxygen is 16. Okay, whoops, I went out of order here. Plus 8 oxygens. All right, then I plug it in. So I have 1 times calcium. Bigger number for calcium is 40. Plus 2 times chlorine. The bigger number is 35.5. Plus 8 times oxygen, which is 16. That's the bigger number. Once again, I'll pause. I got 239 grams per 1 mole. All right. Will you do the practice problems now? So here's the first practice problem. And here's the second practice problem. And chemistry is sort of confusing once in a while. This time this is an I. So this is talking about sodium, iodine, and 3 oxygens. So hopefully that helps. Go ahead and give those a shot and turn them in for me to check.